welcome back to the channel Maths with Berlin. So this is a part 2 video of the matrices and determinants and eigenvalues topic. So as promised, we will be sharing the solution to the homework problem that we have given. So let's get started with the problem. So those who have not tried it still now, they can pause the video right now and give it a try. So I hope that you have all given it a try. And now for the solution part. So let's give a formal reading to the question. So it is given that A is a 3 cross 2 matrix and B is a 2 cross 3 matrix. And it is given that AB is a matrix, right? So AB is a 3 cross 3. AB will be a 3 cross 3 matrix. So let me explain this fact for most of the viewers. So A is a 3 cross 2 matrix, B is a 2 cross 3 matrix, and now their product would be a 3 cross 3 matrix, right? And the product of BA should be a 2 cross 2 matrix. How? So it's like this, right? So it's a 2 cross 2 matrix, right? Now we have got, let's note down the information as we get it, right? We have got one information that BA is a 2 cross 2 matrix, right? We got this information about it. And AB is a 3 cross 3 matrix, that is given to us. Now as AB is a 3 cross 3 matrix and the matrix with all its elements are given, and it is also given that determinant of BA is not equal to 0. So then we have to find the value of the determinant of BA, right? So let's get started with the solution part. So as you can see, I have just done nothing very complicated, just taking things very simply. So follow my lead so that you can understand it nicely. Now, well, first of all, I have just noted down the value of the determinant AB, right? I have noted down all the elements and the value of the determinant so that it's easy for us to check out. And after that, what I have done is I have tried to find the eigenvalues of AB matrix. So how does that help is that when you get the eigenvalue of the matrix AB, what you can do is, as I have said in the lecture video, that is part 1 of the video, that with the help of the characteristic equation or the minimal equation, that is minimal polynomial equation, what you can do is you can replace the lambda with the matrix and the constant term as the constant term, let's say it is minus of 6, so you can replace the constant term with minus 6i, that is identity matrix, and you can replace the 0 with a O, that is null matrix, right? So I just made a revision all through it. So now that's our motive, that taking out the eigenvalues so that we can find a relation between AB and BA by the help of some manipulation, right? So just the shortcut method as shared in the solution using Cayley-Hamiltonian theorem. So we did this simplification, and I prefer that you do this simplification on your own, right? And get it right. This is the value, right? This is the value of the characteristic polynomial. The characteristic polynomial, let me just tell it to you again. Characteristic polynomial is the polynomial that we get after solving this determinant, right? After solving the determinant. And what is a minimal polynomial? Minimal polynomial, that is minimum, let's say minimum polynomial, is the polynomial with single powers, or let's say, if as in the given the question, this is the characteristic polynomial, this one is the characteristic polynomial CHR, let's say CHR, and the minimal polynomial to this would become lambda into lambda minus 9 equal to 0, right? This is the minimal polynomial. You should only take one root, that is one of the kind. If there are two roots of the same kind, like here it is 9 9, right? 9 9 and 0, these are the roots. So you omit one of all the 9s and take only one of the 9s and or 1 0, like that you make an equation, and that is a minimal polynomial. I hope you understand it right? So that is what I have written, whether the minimal polynomial is lambda into lambda minus 9 equal to 0. So now as we know that we have to just replace lambda with the matrix. So the matrix here is AB matrix, right? The matrix here is an AB matrix. Now after that also you have to replace the constant term with a minus 9i, right? You replace the constant term, that is minus 9, with minus 9i, and you also replace the 0 with the null matrix, right? These are the replacements that you need to remember. That is, a lambda changes to the matrix, the constant term changes to minus of sorry, not minus, constant term changes to the constant multiplied by I, that is identity matrix, and the 0 changes to the null matrix, or O. So this is just the value putting of the, right? This is just I just put the values and replaced it. Now after that there is a crucial step that I need to show out to all of you. I'm just magnifying it so that you can see it clearly. So the next step that we do is I just use pre-multiplication and post-multiplication. So what is pre-multiplication is that when you multiply something in the front end of a matrix, and when you multiply something at the post end, it is post-multiplication. That is, at the back end if you multiply something, so that is post-multiplication, and at the front end if you multiply something, that is called as pre-multiplication. So these are all basics of matrices, and what I have done is I have pre-multiplied the matrix with B and I post-multiplied the matrix with A. Now also there is a catch here, that most of the people after this step they commit a mistake here, right? I am showing you the mistake. They write it as AB whole squared minus 9AB, which is correct. But after that they do it like this, that A squared B squared minus 9AB. But this is wrong, right? This is not correct. Why? Because if you see AB whole squared, what does it mean? AB times AB, and you cannot replace B here and A here so that you get A squared into B squared. This is not at all possible, right? So that's the silly mistake that most of them do and end up in a wrong answer. So I tried to show it to you so that you can avoid making that silly mistake. So here is the thing. And now also there is another thing that we have already noted down while we were reading the question, that BA is a 2 cross 2 matrix. Wait a minute. Right, we already noted that BA is a 2 cross 2 matrix. Right. Now after that, what is the benefit of this, right? What is the benefit that how can we use this information that is given to us, that it will be a 2 cross 2 matrix, is shown in the next slide. So here's the next part of the solution. So after the post multiplication, if you see after the post multiplication, let me just magnify it a bit. So after the post multiplication, what you get is that you get 3 parts of BA, right? You get the first part of BA, you get the second part of BA, and you get the third part of BA, right? And in the right hand side, what you get is 2 parts of BA, right? Now I can replace this one as BA whole cube. Don't commit the mistake of, don't misunderstand with BA cubed and A cube, right? This is not what I mean. I mean BA whole cubed, that is BA whole cubed, right? This is what I mean. And this we can write it as BA whole squared, right? Now what I do is I take determinant on both sides. Right? I take the determinant on both sides. After that, what we know is that, let us take that the matrix BA, let us assume for simplicity that the matrix BA is equal to some M, right? We assume it. Now what happens is, you can replace this as M cubed equal to 9M squared, right? Now when you take the determinant, you will end up like this, that is 9M squared determinant. So now M is a 2 cross 2 matrix. So what will be coming out of here is that 9 square will be coming out of it, right? We know that if we take the determinant of 9x, where x is a 2 cross 2 matrix, or let's say n cross n, right? Let's generalize the thing. Let's say x is a general matrix, and we take that x is an n cross n matrix, and we have multiplied 9 in the beginning. So then it becomes 9n, 9 to the power n, into determinant of x to the power n. Sorry, not determinant of x to the power n, it's determinant of x, right? 9 to the power n into determinant of x. So as it is a 2 cross 2 matrix here, so it will become, the value of n becomes 2, right? And you take the determinant of m multiplied with it. So now what happens, I have just made that one clear in the second, in the next step. So now what I can do is, as it is given to us that determinant of BA is not equal to 0. So what I can do is, I can cut this and I can cut this one also, right? So here it will be 1 remaining. So after that, what we can do is, we get what we get is that determinant of BA is equals to 9 squared, that is equals to 81, right? So that's the answer for this video and this solution, this problem. Hope you liked the problem, and please do like, share and subscribe the channel and press the bell icon so that you can get notified as soon as the problems are given. So that's it for today guys. Hope to see you guys in the next video. Thank you.